Oh. So I decided today to focus on proportions, and that's used to solve a variety of word problems and some geometry problems. So we'll be talking a lot about these things called proportions, which kind of look like two fractions equal to each other. With our proportions, most of the time you're going to have to set it up yourself. I gave some example problems here so that we could talk about how to solve it first before we talk about how to set it up. And these are two different example problems. I just wanted to show the difference when x is on top of the fraction versus x being on bottom of the fraction, which actually is, there's not a lot of difference. To solve a proportion, you do something called cross multiplication. You take the bottom of one side and multiply it by the top of the other side. The 7 multiplies by the x, which we can't like plug into a calculator or do really. So 7 times x, and then we go in the other direction, 4 times 3. Bottom of the first fraction multiplied by the top of the second fraction. This one we can actually multiply. Number times a number. So 4 times 3 is 12. So once you've done the multiply part, now we have to do some opposite operations. When we solve an equation, we do opposites to move a number to the other side. We want to get x alone, so we've got to do the opposite of multiply, which is divide. We're going to divide by the 7. So 12 divided by 7, most likely they'll give you the decimal version of this. This is not going to come out nice. So we want to pull up a calculator. And 12 over 7 is really 12 divided by 7, which is 1.71. And if it does come out as a decimal, they would tell you where to round. If we wanted to round to the nearest hundredth, we would need one more digit, 714. So if we round to the nearest hundredths, that's the second spot after the decimal. And we have to decide, do we keep that number the same or do we round up? So should this remain a 1 if we're rounding, or should this round up to a 2? So what do you guys think? Do we keep it a 1 or does it go up to a 2 if we're rounding properly? Remain 1. Good. And Lisa, I just saw you joined. Thanks for joining us. I'm talking about proportions and how to solve a proportion. And we were currently talking about how to round this. 1.71, if we're rounding, the number next to it is a 4. And if it's 0 through 4, you keep the number next to it the same. So 1.71 is this properly rounded. If it had been like 1.718, then it would round up to 1.72. Yep. So if we're going to solve a proportion where the variable's on the bottom instead of the variable being on the top, nothing really changes. We still cross multiply. Bottom of this fraction on the right multiplies by top of the other side. We're going across, which is why we call it cross multiplication. So 18 times x, and then we do the other direction, 15 times 12. So the number times the variable we couldn't actually combine together, but the 15 times 12 we can, which is 180. And then what was our last step? How did we get rid of the 18 and move it to the other side? What opposite operation do we use to move it over? Good. divide by 18. So 180 divided by 18 should be 10, but I'm going to double check. Yep, 10. So there's actually quite a few problems where you can apply these proportions. And normally you're going to have to set up the proportion yourself. So for example, in a shipment of 500 parts, 18 are defective. How many defective parts should be expected in a shipment of 800? So often these should be expected questions are this proportion setup. We look for some of those keywords. And some other keywords is you'll see some matching pieces. Shipment of 500, shipment of 800, that matches. 18 defective, and how many defective, those match up. So when we set up our proportions, we've got to keep those matching pieces together. So on the top line, I'm going to put all my shipment information. So shipment information 1 was that 500. And if we put it in the top of our proportion, to keep the proportion set up properly, there are multiple ways to set it up, but you can set it up wrong. So you've got to make sure whatever you're doing, you put your matching stuff together. So since you put shipment of 500 on top, you've got to put the shipment of 800 on top. We're matching top to top here. Then we're going to put the defective parts on the bottom. And we still have to match up. Here we're saying this is all from the first situation. The 518 went together. That's the first situation. So the 18 has to go under the 500. They're related together because the question told you so. The 500 related to the 18. So we put the defective information on the bottom, and we put all of the first shipment information on the left side. So on the second side, we didn't get told any information. We didn't get told a number. It just asked us how many defective. So if we're looking for something, what should we use here in the denominator? If I can't put a number there, what should we put there instead? Good, X, or any variable really. Most of the time we use X because we're used to it. But we do need a variable in order to solve these. So now we have our proportion set up. I'm going to write it without all of my extra information on it. Sorry, that is 500. Sometimes it's hard to write with a mouse, so it looks a little funny. So now we're set up to do our cross multiplication. What things will multiply together? If we're doing our cross multiplication, what do we multiply together? 18 times the 800, good. That's one of the directions. Which I cannot do in my head, so I'm going to plug that into a calculator. 14,400. So then we have to multiply one other set of things. What else do we multiply together? We did the 18 times 800. What's left to multiply together? Good. Everyone got that correct. 500 times the X. Which we can't actually multiply. Can't multiply a number and a letter actually together. But we can now use it to do our opposite operation. We said the opposite of multiply is divide. So 14,400 divided by 500. 28.8. Did I type that in correctly? 14,400 divided by 500. 18 are defective. I'm wondering if I copied the problem wrong over. I think we should have an exact answer on this. So now we've got to go through and double check. If this happens on the OGT, you're like, well, my answer is probably 30. That's pretty close. But it didn't say to approximate. So it's a good idea to double check. So we put those two together, 500 over 18. How many defective parts should be expected in a shipment of 800? So we matched it up. So we set our proportion up correctly. Now I check, did I plug it into the calculator correctly? Super easy to mess that up. So 18 times 800, still 14,400, and divided by 500. So I may have just copied the problem correctly when I typed it in. Last time I actually took screenshots, but it was hard to see, so I tried copying them over. So I apologize, it didn't come out exactly. It probably was just a typo when I was typing it in. But the theory is still sound. You still set up your proportion, still cross multiply, still solve. Okay. So another example, I just have a couple for us to practice. Approximately 1 out of 14 people have hazel eyes. If the world's population is about 7.2 billion, estimate how many people have hazel eyes. So this time, for sure, the word estimate is used. That means your answer is going to be close, but not exactly. So whatever we get, we just find the closest multiple choice answer. So now we need to set up our proportion. What should we put first? From our key information, we have the 1, the 14, and the world's population. Okay, so one person said 7.2. When you start, you can actually start with whatever you want. So one person said 7.2, one person said 1. You're both right. As long as once you set it up, you keep everything in the same order, both of these versions are correct. You could start with 7.2, you could start with 1, then we have to keep the matching information. So if we start with the 7.2, the question was how many people have hazel eyes? That's our variable. So this was hazel eyes, and this is the total population. Now we need to do the same setup on the other side. So on the other side, we have to put hazel eyes on the bottom still, and the total of the information they gave us. So now we're restricted. What does this fraction have to be using only the 1 and 14? That's our only information left. Should we put 1 over 14, or should we put 14 over 1? Okay, so you guys are saying 1 over 14, but one person says 14 over 1. So a couple different answers. So let's look at the information again. We need the hazel eyes on the bottom. Was the 1 or the 14 referring to people with hazel eyes? Which number is actually saying these people have hazel eyes? The 1. 1 is how many people have hazel eyes out of just 14 people. That means it must go on the bottom. Does that make sense? We have to line it up. We have to keep that information the same, or else then your proportion gets a little messed up. Good. So again, you could have started with the 1. That's fine. Then when you set up your information, you just keep the matching spots in whatever order you chose. If we did 1 hazel eyes out of 14 random people, then you're looking for how many people have hazel eyes out of 7.2 billion people. And it's important to state this is 7.2 billion. When we actually plug it into a calculator, we're probably going to want to write this out as 7,200,000. So that's only millions, 1 more, billions. Okay. So hundreds, thousands, millions, billions. Just for then when we plug it into the calculator, it's easier to understand what our answer means. So we have it set up. We cross multiply to solve. 1 times the 7.2 billion or 7,200,000,000. It's hard to say those big numbers, but that number, 7,200,000,000, 1, 2, 3, 1, 2, 3, times 1 doesn't actually change the number. You multiply by 1, still got that big long number. And we cross multiply in the other direction, x times 14. I usually write the number first, 14 times x. It's just easier because we see it this way more often. And then we do our opposite. So what was our last step with these proportions every time? It's our opposite. Good. We divide by the 14. So this big long number divided by 14 is, there's our decimal, 1, 2, 3, comma, 1, 2, 3, 514 million. And I'm not even going to write the whole number. I'm just going to say 514 million, which is our answer choice D. Now, the reason I wrote this out as the actual billion, if we did just the 7.2 and we ended up having to do 7.2 divided by 14, it might look a little weird. Since 7.2 was in billions, this is saying 0.514 billion, which is 514 million, which can be kind of hard to conceptualize in my mind. I don't really know that this means millions because it's a decimal for billions. But you could still see what the correct answer was because there's still only one that has the 514. So even if there is a little variation, it might be something like that where it has to do with the fact that they said 7.2 billion instead of writing out the number 7,200,000,000. So just something to watch out for. So we've set up a lot of proportions for word problems, and now we're going to switch over to a little bit of geometry. When you use geometry to set up a proportion, it only works for something called similar figures. So the questions that have the word similar in it, those are ones where you can set up a proportion. They will have to tell you these figures are similar. So similar is basically 2 shapes that are the same shape, different sizes. There's also the word congruent in geometry. Congruent is same shape, same size. Maybe it's just been moved around or rotated. This time it's same shape, different sizes. So it'll change the length of the sides. The inside angles will actually be the same. If these are similar, and we know this angle is 70 degrees, then the angle inside here would also be 70. So same angles, different size sides. So we can still set up our proportions the same way though. They're actually very similar in our setup because we've still got to keep that matching information. So I always like to put it into the first shape. The left side will be all the information I want from the first shape. And the second side will be the second shape. But then you have to match corresponding pieces top to top and bottom to bottom. So we call it corresponding when it's in the kind of the same spot, but it's a different size. So the first shape, we have X that we're looking for over one of these other sides. Now what's confusing though is we have two options. Which one do we use? We always want to pick the one that has a corresponding side. So of the 3 and of the 4, which one also has a side labeled in the same spot? Should we use the 3 or should we use the 4? Good. We should use the 4. The 3 is kind of a red herring. It's extra information specifically to kind of confuse you. Gives you the extra stuff, but we don't actually need it. So from the first shape, we're doing X over 4. So then we have to keep the same order on our second shape. We did left side and right side. Left was our top, right was our bottom. We've got to keep the same order. So should we do 9 over 12 or should we do 12 over 9? Which one will keep the correct order of doing the left corresponding to the right? Good. 9 over the 12. So as you practice these proportions, you'll get much more confident about setting up, what order goes where. You just have to really keep in mind, I can't stress it enough, that you have to keep those matching and corresponding pieces together so that you set up your proportion correctly. But then we solve it the same way we've been solving all of the others. We cross multiply and solve. 12 times x is 12 times x. We can't simplify it. 4 times 9, you could write 4 times 9, or now that we're getting a little more practice, we could just do the multiplication. That gives us 36 and write down the answer. Cuts out a step. But that's up to you. It just depends on how many steps you prefer writing out. So we do the opposite now of multiplication and divide. The opposite gets rid of the 12 on the left side and moved it over to the right. And then we do that division. 36 divided by 12 is 3. Now, especially with shapes, you can use some logic as well to make sure your answer makes sense. If we did this whole process and we ended up with an answer of 11. So 11 to 4, 9 to 12, you can say, well, this left side was smaller than the right side. That should hold true over here. So always kind of double check your answer. Make sure it makes sense. And if it doesn't, go back and say, okay, what did I maybe do wrong? So another thing they can do with these shapes is they can rearrange them. We had it in the same orientation before. The left side matched to right. Now they've been flipped around. So our first rectangle, we still pick the information from that rectangle. We have our 2 and our n. Those are both from the first rectangle. Our second rectangle, we have to do the corresponding pieces. We can't just go, well, 2 was higher than n, so this is definitely 7/20. We have to look at the corresponding pieces and say 2 is our shorter side of our rectangle, so it has to correspond to the shorter side of the other rectangle. So which one is the shorter side of the second rectangle? 7. No, 2 answers. So we had a couple people say 7, a couple people say 20. So shorter side, we can tell by the actual numbers on this shape, but you can also tell by the sides. This one is actually physically smaller than this side right here. So the 7 is the shorter side, and it corresponds to sorry, gotta start that sentence again. 7 is the shorter side, and it corresponds to the 2 that's also the shorter side. What happened is they rotated the rectangle when they made it bigger. So you're actually looking at the picture and saying which piece is actually physically shorter and which piece is actually physically longer. So once we have that set up, again, we cross multiply. So I'm gonna let you guys try this one on your own. I want you to go through, since we've seen the cross multiplication process a couple of times, I want you to go through and solve it and just tell me, what are you getting for n? And we are going to need to round. Let's round to the nearest tenth. So we do the 2 times 20 divided by 7. 2 times 20, oops, divided by 7. So we get 5.7. When we round it, the nearest tenth is the first number after the decimal. We're going to decide, does this stay a 7 or does it round up to an 8? And since the number next to it is a 1, we keep it a 7. So the most exact answer is the 5.7, even though 5 is technically correct. Since it said round to the nearest tenth, we do need to include that decimal. So one more geometry. This one looks a lot more complicated. They've set it up so that there's 2 shapes kind of put together. We don't really know what corresponds to what. So we do have to, and there's a whole lot of information. They labeled these all using the letters. So the question says, ED and AB are both perpendicular to BD. Perpendicular, another word, geometry involves just knowing a lot of definitions. So perpendicular means they meet at a 90-degree angle. Which in the picture, you'll also notice this symbol here, that little kind of square, that also means 90 degrees. So ED and AD are both perpendicular to BD. They're saying ED meets BD at this 90-degree angle. And AB meets BD at this 90-degree angle. Ultimately, for this particular question, it's not super important information. A lot of the geometry questions, they have to give you these definitions because if they didn't meet at a 90-degree angle, we couldn't set up this proportion for this kind of question. So sometimes there's a lot of extra information in these geometry problems. So let's keep reading the question and see what the actual important information is. But I did want to go through these definitions because they're good to know. Sometimes you do need that information, just not on this problem. So in triangle ABC, the length of AC is 4 centimeters, and they already have that labeled for you. A to C is 4. And the length of AB is 2 centimeters, which I forgot to label when I was drawing it out, but we can label it right now. A to B is 2 centimeters. If the length of EC is 8 centimeters, what is the length of ED? So they want this side up here. So when it's all this different order, sometimes setting up the proportion can be more difficult. But we still want to split it into our 2 shapes. We have a small triangle, and I'm going to actually draw them separate. Sometimes it helps to separate it out so that there's less to look at once. Small triangle, and we have the big triangle. Which had the 8 and the X. So once you've identified all the important information, again, that only told us that this was a perpendicular angle so that we could know we could set up a proportion. We only really care about the sides for this problem. Then we can set up our fractions. So what should we do for our first fraction of our proportion? Let's make it our small triangle. Should we do 4 over 2 or 2 over 4 from our small triangle? Okay. So again, we got 2 sets of answers. Some people said 4 over 2, some said 2 over 4. For the first one, you're both right. You could say 4 over 2, you could say 2 over 4, and either one is fine. But once you've decided, so I picked 4 over 2, once you've decided, we must keep the same order on the second one. So what makes these 2 pieces special is 4 is kind of this tilted line. I'm going to call it the tilted, which I totally spelled wrong. Let's try that again. Tilted line. And 2 was the horizontal line. It's just going straight across, which limits us. We've got to go the same order on the second fraction. Now we have to match. If we do the tilted line from the big triangle over the horizontal line of the big triangle, should this be x over 8, or should it be 8 over x? So again, getting multiple answers. One says 8 over x, one says x over 8. So again, we have to match up. If we started with 4, 4 was our tilted. We have to start with the tilted line, which is the 8. Our tilted line was the 8, so it's got to be 8 over x. These proportions, the solving part usually is pretty straightforward. It's the setup part that can really get you. And you've got to make sure you're going in that same order. But once you have it set up, we cross multiply and solve. Four times x is just 4 times x, and 2 times 8 is 16. Then we divide both sides by the 4, which one side it just cancels out and gets rid of it. But the other side we actually do the division. 16 over 4 is 4. Again, sometimes, especially where it's multiple choice, sometimes you can just use a little bit of logic. Maybe you just don't remember how to do a problem like this. It's still a good idea to take a guess. You don't lose points for, putting an answer down. So you can say, well, nowhere in my problem do I see any square roots right now. Likely it's not these. Probably not those. So then you have to only pick between the 4 and the 16. Looking at the picture, the 8 physically looks longer than the X spot. So it's probably going to have to be the 4 because it's smaller than the 8. So that's not, the best method, but using some logic can help you maybe get a question right that you just weren't 100% sure about how to solve. So that's all I had prepared for the proportions. We talked about the word problem type of proportions and the geometry problem types of proportions. There's also quite a few percent type problems. You'll see a lot of percents on the OGT itself. So the next couple of problems are all going to be about how to solve percents or how to use the percents. Usually the percent problems are multiple steps. You don't just do one thing, you have to use the percents and then do a second thing. All the OGT tests they have online that I looked through, the percent problems are always do 2 things at least. So this question says, 530 people were surveyed about their favorite kind of drink. The results are shown in the graph below. If half of those who like coffee were men, how many men chose coffee as their favorite drink? So again, this is going to be a multi-step problem. We're not just going to do one thing, we have to do a couple. Also, they are a little bit tricky. 530 you might ignore because they wrote it out, but that's a key number. We have 530 people total. So specifically, they wanted coffee drinkers. So we want to figure out how many people just drink coffee. We want to know what's 20% of 530. So when we're solving percents, we can't actually use the number 20. We have to change this to its decimal version in order to use it. So you might know from previous math classes, usually there's a decimal at the end if there's not one written in, and if you move it 2 to the left, that's where your decimal ends up. This changes to 0.20. So if you know that way and you're comfortable that way with that way, use that way. I always forget, how many decimal places do I need to move, or do I need to put an extra 0 in? So usually what I do instead is I say, well, every percent is out of 100. The biggest percent you can have is 100%. So if we do 20 divided by 100, that also will change it to the correct decimal. Which gives us the 0.2. So I chose 100 because all percents are out of 100. So you would use 100 every time. If they gave us 7%, we would still have divided by 100 to get the correct decimal. Once you have that decimal, and again, that was just a random, 7% was random, but if you get your decimal for the problem, 0.2, then you multiply them together to find the percent of is going to really mean multiply. So 0.2 times 530. And again, a lot of these problems you just need a calculator for. Doing 0.2 times 530 by hand is pretty hard. So we type it into our calculator and get 106. So this is where you can make a mistake. 106 is on our answer choice. But they didn't ask for all the people who drink coffee. This is all the people who drink coffee. They asked just for the men who drink coffee. So these multi-step problems can be killer because usually they put whatever you get in the middle as an answer choice, and you're like, oh, that's there, I'm done. So always look for what did the question actually ask. It asked how many men chose coffee. And this is not specifically just the men. It said half of the people who drink coffee were men. So how can I find half of 106? What do we do to find half of 106? Good. Divide specifically by 2. 106 divided by 2, we'll cut it in half. So now we go to the specific 53 men drink coffee because they asked specifically how many men drink coffee. So be careful of those in-between answers. See if maybe there's extra steps that you still need to do. So here's another, again, multi-step problem. The percents, usually there's at least 2 things to do. So Kim has a coupon for 30% off. So that's an important piece of information. 30% off on one item at her favorite store. She picks a skirt for $43, another key piece of information. How much will Kim pay? That's what it's actually asking for. That's not just important, that's super duper important. That's what we need to answer. How much will Kim pay? If she gets 30% off and then pays a 6% sales tax. So with percents, sometimes we need to know if we're going to minus or add. So when we do percent off, is percent off going to be minusing or adding? Minus, subtraction, good. Percent off, that means minus. Okay, how about the sales tax part? For sales tax, is that taken off our total or do they add it to our total? Good. So sales tax, that's added to our total. And that doesn't have any math keywords. We just need to know, well, sales tax, the government is collecting more money on top of the purchase we're making. So let's start with 30% off. The percent we're going to divide by 100 to get the correct decimal. Which is 0.3. And then we multiply by the actual item. 0.3 times the cost of the skirt. So this is the percent, but in decimal format. It's the only way we can use it. And this is the cost of the item. So 0.3 times 43 is 12.9. Now, since we are doing multiple steps, we don't want to round. We want to keep these as exact as we possibly can. So we're going to keep it as 12.9. But this is our percent off, so this is where the subtraction comes in. The original price of the skirt was $43. Then we need to subtract the percent off we just found. So we've used this 43 twice. We used it to find the percent off, and we're going to use it to find the actual cost. So we do that subtraction, 43 minus the 12.9. We get 30.1. But that's not the final answer. That's how much we got off. Now we have to go do the sales tax part. Like I said, these are usually multi-step. So now the sales tax part, we're using our new number. They're only going to charge a sales tax on this $30.10. 30.1 is $30.10. So we do the same process, but with our 6% sales tax. We're going to do the 6 divided by 100. And this is going to show you exactly why I always just do divide by 100. A lot of people, when they try and just move the decimal, would say that this is going to be 0.6. But 6 divided by 100 is 0.06. That 0 is often left out, and it's going to throw off your problem. So we do the percent times the cost. That doesn't change. $0.06 times the 3010. We're using our new cost, what we got after we took the amount off. Is 1.806. Again, don't round. It's a long number. We're going to keep it until the very end, and that's where we'll round. And then we need the sales tax. So we take the original, which in this case is the 3010 now. That's the number we're working with, plus the sales tax. $30.10 plus 1.806. Oops. Plus, got to start that all over. $30.10 plus 1.806 is 31.906. And with money, they're never going to tell you where to round because it's assumed you know where to round. Money is always 2 decimal places. It's always the hundredths place because we need our dollars and our cents. So this 0, we have to decide, is it going to stay a 0 or is it going to round up to a 1? And we tell by the number next to it. So the 6 will tell us whether we keep it a 0 or whether we round it up to a 1. Good. We round it up. The 6, if you have any number from 5 to 9, that's rounding up, which is 31.91. And there's only one answer close to that. So even if you weren't sure where to round, there's only one answer that's anywhere near it. So I have one more example problem for percents. Again, there's almost always multiple steps if they involve percents. So on this one, Monique is buying her first home. The home is priced for $250,000 and she currently has $45,000 in the bank, which is a lot of money to have saved up. So good job, Monique. If Monique wants to pay 15% of the price of the house up front. So again, key piece of information, 15% of the price of the house. How much money will she have left over for furniture? So another key piece of information, what they're actually asking for. How much money she has left over. They didn't ask what 15% of the house was. They asked how much money is left over. But we do have to find 15% of the price of the house in order to answer the question. So we always take our percent, and what do we always divide that by to change it to the correct decimal? What should I divide the 15 by? Good, 100. And again, if you prefer the moving the decimal over version and you're comfortable with that, do that. Whatever way works best, as long as you get to the fact that this is 0.15. So then we take the percent and we multiply it by the price of the house, because it said 15% of the price of the house. So which of the numbers was the actual price of the house? Good. The 250,000. That's the actual price of the house. And I'm going to leave the comma off so it doesn't look like a decimal. So now, calculator time. 0.15 times 250,000, 37,500. Again, we'll see that that answer is on our list, but that's not what they asked us for. That's why we have to really stress, what is the question actually asking? So if it asked how much money is left over. So now we use the 45,000. What do I do with those two numbers, the 45,000 and the 37,500? If we're looking for leftover, is that addition, subtraction, multiplication, or division? Good, subtraction. So leftover was a keyword to tell us to subtract. So we do the 45,000 minus the 37,500. Which gives us 10,000. Oh, okay. Always check your calculator work. What did I type in wrong on my calculator? I don't know if you can see the little numbers up here. I made one little mistake, and it's super easy to do all the time to just hit the wrong number. And you'll notice 10,500 is not on there, so we double check. I should have typed 37,500 instead of 34,500. Minus 37,500. So always check your calculator work. The calculators on the OGT can kind of be sticky too. If you don't hit the number hard enough, it might just leave a number off because they only allow you to use a TI-30X2S. It's a specific type of calculator. And there are some issues where you might think you've hit a key and it didn't actually go through. So always double check that. So the final answer is 7,500, even though one of the middle step answers was also on our list of answer choices. So that is all I wanted to cover today. We talked about our proportions and our percents. I am doing another session on Thursday where I'm going to cover new topics. I'm trying to get as much covered as possible before the June OGT, so I decided to up it to 2 times a week. So Thursday at 6 p.m. If you can't make it then, I'm going to record it as well, and I'll send out the link after it's done. Any questions before we end the meeting?